Wait, is it going? Oh,
It's going.
sorry. I didn't hear it do the dink thing. Okay, so the weight of a balloon is 3,000 newtons, and the lift force lifting it up, acting on it is 3,300 newtons. What is the magnitude in the direction of the net force down? What do you think?
You could probably do it without a free body diagram,
Oh,
but
yeah?
a free body diagram will help understand.
Hopefully you can do it, but we will just visualize it. So it's at 3,000 newtons down, right?
Yep.
That was the force of gravity down, and the lift force
Is up.
is up.
3,300 newtons.
And if you want to call that the force lift, I mean, you can, doesn't matter. And so how do we calculate that force? What is the
Just
what's
add
the
them
force?
together.
You add them
The
together.
sum. It's the
So 3 newtons. Oh, and this is a negative number 2, yes?
yeah.
I always forget to do that. Plus a negative 3,000 newtons. And what's that going to get us?
A, B, C, or D, boys and girls. It's not A or B, I promise you. 300 newtons up. Did you get it?
And that would be letter D.
Sweet.
Okay. If the weight is 3,000 newtons, what is the mass?
Ooh.
Okay. Let's
that?
go back to. Oh, and you guys, you can. What I really actually suggest you do is instead of G, we make instead of A, let's make that a G.
G, the acceleration due to gravity.
Yeah, and both are right, but this is more right. Okay, so if the weight is, what is the mass? So let's try and figure out what the mass is, right? So I'm gonna go ahead and just divide by G. So my mass is gonna equal the force net divided by G. What was my force net? 300 newtons up.
Well, no. Now, what we want to know is the weight of the balloon, and the weight of the balloon. We know the weight is 3,000 newtons.
Sorry.
So add another 0 to that thing.
I was thinking of the other one. Okay,
Yeah,
let me get rid of this.
No, okay.
Wait, it wants to know what the mass is, right?
Yeah.
So if the weight is 3,000 newtons, what is the mass? Can we just divide by G? Is that what you were saying?
That's all there is to it.
Yeah, I did have the right thing.
You
up
did
there.
have everything in there.
Divide by G. Sorry.
Oh, ye of
I
little
thought
faith.
I thought I skipped the question.
No.
The G is going to be what? Negative
9.80.
meters per second squared, and then 3,000 divided by negative 9.80, and I get negative 306. We'll call it.
300. No, it's not going to be negative because they're both negative. So
Yeah.
306 kilograms.
Kilograms.
Sweet.
And did you guys see what we just did there? Right? We realized that the weight is down.
Yeah.
Right. This is our weight right here.
And the acceleration due to gravity is also down.
Yeah, and so you can catch yourself. You can be like, okay, wait, the mass can't be a negative number. What did I do wrong up here?
Yeah.
Oh, if the net force is 300 newtons up, what is the acceleration?
Oh.
So if the net force equals what is the acceleration? So we've got mass times acceleration, and we want to know the A, right?
Yes, ma'am.
So A equals force net divided by M. Force net is
300 newtons.
300. It says that again in the question right there.
It do.
Divided by what was our mass we just found out?
306.
306 kilograms. So 300 divided by 306, that's going to be close to 1. 306. I get 0.9.
We're going to call that 1.
Yeah, we'll call it
1 meter per second squared.
1 meters per second squared. Okay.
In the up direction. All right.
Oh, yeah, in the up direction. Up. Okay. Up we go. Or in the positive direction. Okay.
Challenge.
Ooh, goody. A skydiver jumps out of a balloon. As she falls, what happens to the velocity, the weight, the air resistance, the net force, and the acceleration?
Increases, decreases, or stays the same. Make a choice. Right now, what do you think's going to happen? A balloon is just staying in one spot. Skydiver steps out, she starts to fall. As she falls, what happens to these things?
Close your eyes. Imagine
More,
this is you.
less, or the same?
Less or the same. Okay, so to answer this, let's go ahead and do some stuff, some drawing.
Free body diagram's a powerful tool. So we've got 4 dots here. You first step out of the balloon, after falling for 2 seconds, after falling for 10 seconds, and at terminal velocity. Question mark. What the
Terminal
deuce?
Velocity. Terminal velocity.
All right.
Okay. So, let's start with our first one here.
Well, what's going to be the same in each one of them?
Well, actually, all the way through our force of gravity or our weight is going to be the same, right?
Yep.
Did it say how much I weighed?
No.
No, doesn't matter. All we care about is big picture stuff here. Now, my arrow is going to be the exact same for the whole time because my mass is not changing. Okay.
So when they first step out of the balloon, they haven't really started falling yet. It's the instant after they step out of the balloons. So what's the velocity going to be?
So when you first step out, your velocity is going to be 0.
So there's no wind blowing up, so your net force is going to be the same as the force of gravity.
So we're gonna have, and so this is like right here, up, right?
Yes.
Right before you step out. So you
Oh,
haven't really
do that
moved.
again. Let's get the whole thing.
Okay. Right
There you go. I like that.
Right?
That was good.
And-
Now it makes sense to me.
And so our net force is all down. Okay, and these arrows are the same.
It's going to be equal to the force of gravity.
Yep, net force is down.
That means the acceleration is going to be,
Means our acceleration is going to be down too, right?
it's going to be g.
Oh yeah, exactly. Negative 9.8 meters per second squared.
Sweet.
Okay. now
After
for-
2 seconds,
So now I've stepped out and I woo.
Now you're
two,
fine.
right? Does that look cool in the video?
that looked
Okay,
good.
cool.
Yeah, you
Okay,
kind of disappeared.
So now we have some air resistance, right?
Yeah, just a little
Just
bit.
a little, yeah, just a little bit. Meep, this little guy. Okay, so we have to add these two together in our heads.
You've got some
right?
air resistance because now you're falling, so you've got a little velocity down.
Ooh, yes. You know what? I'm gonna make the velocity purple so I can have a different color up there. Velocity equals 0, and my velocity is gonna be. I just have a little bit of velocity.
That's right.
Like
Enough to
that.
get some air blowing.
And what about our net force? Is
Well-
it still down?
Still down, but it's
But-
not as much as we had before.
Why not?
Well, because you got some air blowing up.
Yeah. So this net force is this plus this together.
Yep.
And then what about our acceleration?
Yeah, well, if the net force is less, the acceleration's got to be less. It's going to be less than g.
Okay, so I'm gonna say acceleration. Couldn't commit to an A or a G right there. Is less than g.
I like that.
Yeah. We're not going as fast.
Nope.
Okay, so now after 10 seconds, I'm like way down there. We're gonna have more air resistance,
Got more
right?
air resistance. Yep.
Okay. So go maybe a little less. Those look a little bit too equal. You know what I mean?
Yep.
I don't want to equal this one down here. Okay, the force of the air. And
So now your velocity down is greater
even greater.
because you'd be falling.
Go like that.
Yep.
Okay, net force. Now, the net force again, we have to look at both these two things.
Ooh, it's going to be a lot less.
It's going to be a lot less. I'm going to make it like this.
I like that.
Force net. And
If
then
the net force is less, what about the
it's
acceleration?
going to be less. Even less than it was before. That's double less. Not double, but
Yeah, much
know,
less.
Much less. Okay, now terminal velocity.
Well, what happens when you're falling so fast that the air resistance is equal to the force of gravity?
Okay, well, you said something important there. Our air resistance is equal, so let's go ahead and make these equal to each other. Force of the air. Were those people in the I Fly video? Were they at terminal velocity?
Well, what I would say is the force of the air up was equal to the force of gravity down when they were just floating.
Okay.
And they turned it up and they turned it down, they went up or down depending. That changed the net force acting on it.
Okay, so if I was to step out of an airplane after once I've reached my terminal velocity, the fastest possible speed I could go, right?
That means you're not going any faster.
It's gonna be getting faster and faster here, right?
What's the net force now?
Ooh, well, these two are equal to each other, and it was already getting really, really small. At this point, our net force is gonna be 0.
If the net force is 0, what does Newton's second law say about the acceleration?
It's gotta be 0. So that means I'm not accelerating.
Boys and girls, what is acceleration?
The rate and change of your speed over time.
That's right. So if the velocity is not changing, that means you're falling really fast, you're just not going any faster. That's the maximum velocity you're going to hit.
Yeah, and you're going at a constant velocity. You're not speeding up, right? So,
That parachute better work, though.
let's hope. So, terminal velocity occurs when the air resistance on a falling body equals the weight. The air resistance on a falling body equals the weight.
That's a definition right there.
And if you are getting confused by the term weight, force of gravity, weight, same thing.
Yep.
During terminal velocity, the net force is 0, and then the acceleration is 0.
I think that Eureka video talked about weight and force of gravity. Yep.
Okay.
So
Back to
now,
this
can you
question.
answer, how did you do on these?
So let's talk through this. So a skydiver jumps out of a balloon. As she falls, what happens to the velocity? Well, what did we see here? The velocity is my purple. 0 at the
0.
beginning.
A bit more, a bit more. It
More.
increases.
It increases. So you should have an up arrow here, or write the word increase. What about my weight? Weight is my green arrow.
That depends on the mass.
And
Mass
is it
is
ever
not changing.
Nope, it's gonna be the same. How about my air resistance? Nothing. More, so increasing.
Increases.
Net force.
Were you right about this, boys and girls?
Okay, so it starts off as a large net force, and then it decreases because once we reach terminal velocity, this and this are equal,
'Cause
canceling each other out.
Faster you go, the more the air resistance is, and that cuts into the net force.
And then lastly, the acceleration. What do we see here?
Whatever
So
happens to the net
faster.
force, that's what happens to the acceleration. It decreases.
Okay,
And I think that's all.
that's it. Oh, there it is. That's it. Do we have homework for them?
We'll think of something, huh?
Okay.